Hello. So, as part of this assignment, I have picked the paper Hotspot Mitigation for the Masses. This paper was authored by Fabio Hermanier, Aditya Ramesh, and Abhinay Nagpal. This was presented in the ACM Symposium on Cloud Computing 2019. And this is the paper link for the same. So let's look at the problem statement first. So we know that with the advent of cloud computing and cloud servers everywhere, we now have a lot of cloud servers that are being used by different people or different companies, different enterprises. So to maintain this performance of the cloud, when so many applications are dependent on it, a lot of companies have been using VM scheduler. This VM scheduler is basically going to observe the resources, the softwares that are using the cloud, and whatever currently doesn't need to be on active mode or doesn't need to be on at all, it will simply go and switch it off or put it on standby. This is very important in so as order to maintain performance in the IaaS cloud. However, since there are a lot of private clouds and each cloud will have different varied workloads, there is not a simple single key that fits everything, and one particular solution won't work for all. So at this point, it is very important to look for schedulers that overcome this diversity so that they can maintain the performance uniformly across different workloads. So for this particular problem, the authors have used the ADS algorithm. So the ADS is basically standing for Acropolis Dynamic Scheduler. It's a background service that runs in controller VMs that periodically analyzes the clusters to identify the hotspot. Hotspot is basically any cloud that is using CPU usage at one particular point of time, and it can support any hypervisor that is capable of live migration. This ADS thing is comprising of four components. First is the data collector. So the data collector will periodically measure the capacity and utilization of the CPU, the input-output devices, and the memory resources. Along with that, it will also measure the configured resources and resource utilization for each VM, and these measurements are stored to track the historical resource consumption and are then used to characterize that particular workload. Next up, we have the hotspot detector. So the hotspot detector is going to analyze the workload periodically. By default, it is set to 15 minutes, but we can change it as per our requirement. And it will report any hotspot that currently exists or the need may arise in the near future. By default, it considers a hotspot on a node if its CPU or its storage controller usage exceeds 85% of the node capacity. Next up, we have the mitigation planner. So let's say at the second step, the hotspot detector has actually flagged a hotspot. At this point, the mitigation planner comes into the picture. So it is going to use the data collector measurements to compute a mitigation plan. And this plan is basically a sequence of VM migration that will remove the hotspot while making sure that the resource demands and placement constraints for all the VMs are met. This is computed by using a specialized version of the scheduling framework called Better Place. And finally, we have the plan executor. This plan executor is going to execute the mitigation plan by interfacing with the hypervisors of the nodes, and it will use that to migrate to the selected VMs. This migration tasks are done optimistically without blocking existing user operations so that none of the application crashes. Next up, we have the novelty. So, as specified before, the ADS method is actually an existing method that was developed in 2016 to 2017. But with this paper, the authors have proposed certain changes to improve upon the existing framework, making this approach a novel approach. So, some of their approach, the novelty comes from the approaches mentioned below. First up, they have said that for the mitigation plan, we should be using an exact approach to compute and validate it. So for that, they have suggested two steps. First is the optimization phase. We should have an optimization phase where the algorithms are checked and we use the algorithm that is giving us the best performance, which will reduce mitigation for 25% of the cases and reduce migration for 13% of the cases. And secondly, it is said saying that the mitigation request should be set up inside the dataset itself. Next, they have said that instead of having just a rebuild mode where it tries to mitigate the hotspots, we should have a repair plus rebuild mode. This is going to improve the performance considerably. Thirdly, they have said that the VM placement problem should be considered as a resource constrained project scheduling problem and not a VPP problem. Fourth, they have said that we should use knapsack filtering. And finally, we should be using cluster defragmentation and clusters. Next, we have the critique section. So, with this paper, our authors have proposed novel changes to the existing ADS framework. And to do so, they have used the Better Place framework, which is basically an extensible VM scheduling framework. This computes placement of VMs that satisfy the resource demand and schedule actions to achieve this new placement. For this particular approach, the authors have used a pulse dataset to test their approach, and the maximum size of the clusters have been kept at 64 nodes. However, even with the approach, the novel approach that the authors have proposed, there are still certain issues that may flare up in due to long usage. So, firstly, the changes that have been proposed by the authors are mainly impacting the outlier conditions. The general the general cases still remain the same. So it may happen that in the long run, while the performance of the outliers improve, the performance of the general cases may decrease. Next, because of this uh, constant calculations and everything, the CPU is going to be used very intensively, and this may cause performance issues in the long run, even before a mitigation plan is devised. And mitigation plan is very critical because that is the main thing that is going to tell us which VM has to be migrated or which VM has to be shut down. And finally, we have seen that the repair plus rebuild mode has shown better performance, but it is possible that the scheduler has spent so much time on repairing itself that the entire time has run out, and because of which it has not moved to the rebuild mode. In and if we look at the case standalone, the rebuild mode would have actually solved the problem at a much faster pace. Scope of improvement. So, looking at the critiques, I would suggest that firstly, the computational overhead has to be reduced so as to reduce any performance, so as to make sure no performance issues are coming up. And secondly, for the repair and rebuild mode, the algorithm should be intelligent enough to see if the repair mode is taking too much time, then it should switch the rebuild mode and try to resolve this. This will make sure that the problem is not declared as an unsolvable problem. This is a schematic diagram of the ADS design where we can see the host and how it is migrating. And this is the ADS which has the 4 steps: data collector, hotspot detector, mitigation planner, and plan executor. That's all I have. Thank you so much.